In section 17, we will look at quadratic equations, and the use of the calculator is not allowed in this section. So you want to look at the following examples and recall how we have factored in the past. So factoring each of these examples should give you the factors that are given below. So take a few minutes to factor each of the following using the method of your choice. And here are the answers to those. And each time you're getting these factors, please make sure that you're checking your answer by remultiplying them and getting the original expression. You also want to notice that with the signs, if it ends in addition, the signs will be the same. So here they are both going to be the same. That tells me that they're both going to be negatives. This tells me that they're going to be one of each. This tells me that they're both the same, and then that tells me that they're both positive. You also could write this one as the quantity x plus 4 squared. And now try 4 through 6. And here are those answers. In number 4, we want to make sure to realize that there is a GCF there. So we take out that GCF first and then factor, and then we're factoring with 5 and 6. Again, make sure that you're checking each of these answers. Now we're going to solve some equations by factoring. The first step when we solve by factoring is we need the equation to be equal to 0. So in number 7, the first step would be to subtract 9. Once I subtract that 9 over, I'll have x squared minus 2x minus 24 is equal to 0. Then we'll factor and then we'll solve. And here are those answers. So we'll look at number 7 and we see that, like I said before, we subtracted the 9 over, we get x squared minus 2x minus 24. From there, we factor this expression and we get x minus 6 and x plus 4. And then what we do is we set each of these factors equal to 0. So if I were to write out x minus 6 is equal to 0, I'd be adding 6 to each side, and that would give me an answer of 6. If I set x plus 4 equal to 0, I would subtract 4 on each side, and that gives me negative 4. For number 8, I factor this expression. I get x plus 4 twice. I really only need to do this once and write x plus 4 is equal to 0. Solving that is going to give me x is equal to negative 4. Now we would technically get that twice. What we call that is a double root. So you could put dr by that to represent double root. And then for number 9, there is a GCF here that we want to take out. So 2x comes out, and then we would be left with 5x plus 4. When we set 2x equal to 0, we are dividing both sides by 2, and that's going to give us x equals 0. When I set 5x plus 4 equal to 0, I subtract 4, I divide by 5, and negative 4/5 becomes that answer. Now we want to look at solving from a different perspective. If I have x squared minus 13, first of all, we're going to list the operations performed on x to create the expression. So what do we do to x here? Well, first we square the x, and then we're going to subtract the 13. So now what we're going to do is list the operations necessary to reverse the operations on x. So instead of starting by squaring and then subtracting 13, when we start to reverse this, we're going to start by adding 13 and then taking the square root instead of squaring. That would be the opposite here. Now when we take the square root of that, we are going to want to make sure that we're putting that as a positive and negative answer. So we're going to solve this by reversing the operations. We set x squared minus 13 equal to 0. The first step would be to add 13 to each side. That gives me x squared is equal to 13. Then we square root each side, and if I could take the square root of 13 and break that down further, I would do that, but here root 13 stays root 13, and we just need to make sure that we're putting positive and negative options on that. So do the same thing on number 11. So for x, we're going to first of all add 2 to that, then we square that, and then we would be subtracting 7 from that. So when we go to reverse the operations on x here, we're going to start by adding 7. Then we would be taking the square root of that quantity and putting a plus and minus with that. And then our final step would be to subtract the 2. So solving by reversing the operations, we're going to set the expression we had originally equal to 0. Our first step is going to be to add the 7. Then we're going to take the square root of each side here. When we take the square root of x plus 2 squared, it gets rid of the squared, and we're left with just x plus 2. The square root of 7, again, it does not break down, so we leave it as root 7, but we have to put plus and minus there. The final part is getting x by itself. We do so by subtracting 2 over, and then this would be the final answer. Now we're going to talk about completing the square. And we want to start by finding the value of c that's going to complete the square. And in order to get that value, what we do is we take our b value, our middle term, that -10, and we either divide it by 2, or you can think of multiplying it by 1/2, and that's going to give me -5. Then I take that value and I square it. -5 times -5 gives me +25. And one thing to keep in mind is the value that we're getting here should always be positive, because whether we're taking a positive number and squaring it or a negative number and squaring it, that's always going to give us a positive result. So now we're going to solve this equation by completing the square. So here's how this works. We want to have all of the x values on the left side. So I'm going to start here by subtracting over 10x so that I have x squared minus 10x is equal to 2. Now on this side, I want to complete the square. So I need to figure out what I have to add on this side, which I'll then have to add to this side too, so that I get a perfect square over here. And that value, as we talked about up here, is going to be a +25. So I need to add 25 to each side here. From there, I will factor this out. And we've talked about this before. When I go to factor this one, it is going to be the quantity x minus 5 squared. Now, I had to do the same thing on the right side here. So 2 plus 25, that adds together to give me 27. Now from here, I'll have to square root each side. So when I take the square root of both sides there, I'm going to get x minus 5 is equal to plus or minus the square root of 27. Now in this, I can break that down. So as I go to break down 27 there, it is going to turn into 3 root 3. And then I'll add the 5 over, and that ends up giving me x is equal to 5 plus or minus 3 root 3. On the next example, we want to complete the square. So once again, we're going to take half of our middle term there, and then we're going to square that, and that gives us 121. Now we solve by completing the square. So if we're given this expression here, again, I only want the x's to be on the left side. So I'm going to add the 22 over. And once I add that 22 over, then I'm going to need to think about what value needs to go here so that I can complete the square on this side. And we already discussed that up here. So I get x squared plus 22x plus 121 is equal to 22 plus 121. Because I added the 121 on this side, I had to add it on this side as well. Now I factor this, and this is going to factor 2x plus 11 in parentheses squared. This side added up to give me 143. So now I'll take the square root of each side here. That gives me x plus 11 is equal to positive or negative root 143. Again, if I try to break that down, it's not going to break down any further. And my final step here is to subtract the 11 on each side, giving me negative 11 plus or minus the square root of 143. The next thing that we're going to look at is how to solve equations using the quadratic formula. The quadratic formula is up here. We've got negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. And notice that that 2a is below all of this right here, including that negative b that is in the numerator. Now, in order to use that process, the equation has to be equal to 0 here. I end up plugging in. Again, we start with b. b is 1, so the opposite of that is a negative 1. Then it's plus or minus the square root of b squared. Well, 1 squared is 1 minus 4 times our a value, which is 8, times our c value, which is negative 1. And then we're going to divide that by 2 times our a value, so 2 times 8, which is 16. Now if I simplify underneath here, I'm going to start with this side over here. Negative 4 times 8, I'm at negative 32. Multiplying that by negative 1 is going to give me positive 32 for this one. So 1 and 32 combine to give me 33. Again, if I could simplify that, I would, and it doesn't simplify. So my answer is going to be negative 1 plus or minus root 33 all over 16. And that counts for 2 answers. Then for 15, I have to start by adding 2 to each side, and that's going to give me x squared minus x minus 10 equals 0. So then from here, again, I'm taking the opposite of b. So this is currently a negative 1. That's going to make this a positive 1 plus or minus the square root. Taking negative 1 and squaring it, that's b squared. And then I've got to go minus 4 times our a value, which is 1, times our c value, which is negative 10. And then it's all over 2 times a, which is 1. So all over 2. Now from here, when I simplify the inside here, negative 1 squared is going to become 1. Right here, negative 4 times 1, I'm at negative 4. Multiply that by negative 10, this is 40. And then 40 plus 1 is 41. If I could break that down, I would, but it doesn't break down, so we get 1 plus or minus root 41 over 2. And then for 16, I start by subtracting 5x on each side so that I have 3x squared minus 5x plus 1. And then from there, as I'm plugging things in, I've got the opposite of b plus or minus the square root, b squared, so negative 5 squared minus 4 times a, which is 3, times c, which is 1. And then that's all over 2 times 3, so 6. Now on the inside here, negative 5 squared is 25. This all multiplies out to give me negative 12. So 25 minus 12 is 13. And again, that doesn't break down. So my answer is 5 plus or minus the square root of 13 all over 6. Now we change gears a little bit and we talk about the discriminant. So the radicand of the quadratic formula is the discriminant. That's that b squared minus 4ac part. And we need to think about its outcome, and that's going to tell us what type of solutions we can expect. Now, if we calculate b squared minus 4ac and we get 0, that's going to tell us that we're going to get just one rational number, and it's going to be a double root. If I calculate b squared minus 4ac and it comes out greater than 0, we have two scenarios for this. If it's greater than 0, we're going to get two solutions. We have to decide if those are going to be rational or irrational. Now remember, since this ends up underneath the square root in the full formula, the square root of a perfect square is going to produce two rational numbers. If you take the square root of something and it is not a perfect square, that's going to produce two irrational numbers. And then finally we have when our value for b squared minus 4ac comes out to be smaller than 0. Now, if your value for b is 0, you're going to get two imaginary numbers. If your value for b is not 0, you're going to end up getting two complex numbers. So what we're going to do now is a few different steps. Step 1 is going to be to rewrite the equation, and step 2 is to compute the value of the discriminant. And then we want to talk about the nature of the roots. And then finally, for the last part, we're going to solve the equation for x. So in number 1, we start by moving everything to one side, and that part is going to give me x squared plus 5x plus 1 is equal to 0. Next, we calculate b squared minus 4ac. So 5 squared is 25, and then if I do negative 4 times 1, I get negative 4. And 25 minus 4 is 21. And that, because this comes out to be positive, I know I'm going to get two solutions, and from there I've got to decide if they're rational or irrational. Now these are going to be irrational because if I take the square root of 21, it's not a perfect square, so it is going to give me an irrational solution, and it's two irrational solutions. The other thing we're going to do here is we're actually going to solve this equation, and looking at this right here, you can solve it by the method of your choice. Sometimes we'll solve these by factoring, sometimes by square roots, completing the square, or the quadratic formula. The fact that we already know that this is going to give us two irrational numbers, the best idea is to use the quadratic equation. And what we would have here is it would be the opposite of b, so I'd be taking the opposite of 5 to make that negative 5, plus or minus the square root. Well, we already calculated b squared minus 4ac and got 21 for that, and then it's all over 2. If I could simplify that further, I would, but that one does not simplify further. For number 2, again, I move everything to one side, and that's going to give me 3x squared minus 5x plus 2 equals 0. Now when I calculate b squared minus 4ac, negative 5 squared is going to give me 25. This is going to multiply to give me minus 24, and those combine to give me a positive 1. Now again, because it's positive, I knew I'm going to get two real numbers, but I have to decide if it's going to be rational or irrational. Now if I take the square root of 1, it comes out perfect. So because that's perfect, it is going to give me a rational number. I won't have a radical left in my final answer. So now again, we can solve this multiple different ways. Here, I've chosen to factor. I would set 3x minus 2 equal to 0, which would give me 2/3. Or I would set x minus 1 equal to 0, which would give me 1. The other option, though, is I could have used the quadratic formula. That would have given me positive 5 plus or minus the square root of 1, which really just turns into 1, all over 2 times 3, which is 6. And then I would have to simplify that until I got the two answers, 2/3 and 1. For my next equation, I'm again going to start by adding 3 to each side. And my equation becomes x squared minus 5x plus 3 equals 0. From here, I've got b squared minus 4ac. So negative 5 squared is 25 minus 4 times a times c. And that ends up giving me 13. Again, it's positive, so I know I'm going to get two real solutions. And then I've got to decide if it's rational or irrational. If I take the square root of that, it does not come out perfect. So that's why I'm going to get irrational numbers here. When I go to do the quadratic formula here then, I've got the opposite of negative 5, which is positive 5, plus or minus the square root of, we already did b squared minus 4ac, so 13 goes here, and then it's all over 2 times our a value of 1, which is 2. Again, that does not simplify further. And then for number 4, again, we start by subtracting 6x over, giving me x squared minus 6x plus 2 equals 0. From there, if I complete b squared minus 4ac, we see the numbers filled in here. That gives me a solution of 28. Again, it's positive, so it's two real solutions. And I have to decide if it's rational or irrational. When I take the square root of 28, it would give me an irrational number, so that's why this is two irrational solutions. Now to finish this, I take the opposite of b, so negative 6 becomes positive 6, plus or minus the square root of, we already did, b squared minus 4ac, so that goes here, and then all over 2 times, in this case, 1. Now from here, the square root of 28 does break down to 2 root 7. So now I can take this and simplify one more time. 6 divided by 2 gives me 3. 2 root 7 divided by 2 gives me root 7. Keeping in mind that if it only simplified for these two, I could not do it. If it only simplified for these two, we couldn't simplify. It's only because all of the, okay, on the next problem, again, I'm going to start by subtracting 3 on each side. I end up getting 4x squared plus 12x plus 9 is equal to 0. Calculating b squared minus 4ac here is going to give me 0. And because I got 0 there, I know that I'm just going to get one rational solution and that it will be considered a double root. So now I chose to do this by factoring. My factors were 2x plus 3 and 2x plus 3. You could have done that with other methods here, but we end up setting that equal to 0, getting negative 3 halves, and it is considered a double root. For 6, I'll start by adding 1 to each side. That's going to give me x squared plus x plus 1 equals 0. From there, b squared minus 4ac ends up giving me a solution of negative 3. So from here, when I do the opposite of b, that becomes negative 1 plus or minus the square root of b squared minus 4ac is here, all divided by 2 times 1. Now, for this one, I end up taking the square root of negative 3, and that can simplify. I should be taking that negative, thinking of that as the square root of negative 1, which gives me an I on the outside. So I've got negative 1 plus or minus I root 3 all over 2. And again, it came out to be complex here because I got a negative solution. And when we remember that that becomes the square root of negative 3 within our quadratic equation, we know that an I would be coming out, making that imaginary. And then because my b value is 1 here, that's why it ended up being complex. For 7, I'm going to start by subtracting 8 over. From there, step 2 is b squared minus 4ac. Here I'm getting 81 for that. If I take the square root of 81, that is going to come out perfect, and that's why I end up with two rational solutions. Here I have factored that. Setting each factor equal to 0, my solutions become negative 1 and positive 8. For 8, subtracting 4 over first gives me 2x squared minus 3x minus 4 equals 0. From there, b squared minus 4ac gives me 41. And because that's a positive number, I know I'm getting two real solutions, and they're irrational since when I take the square root of 41, it would come out to be irrational. So the answer here, I would have the opposite of b, so positive 3 plus or minus the square root of what we just got here, 41, and then all over 2 times 2, which is 4, and then that doesn't simplify further. And then finally for 9 and 10, for number 9, we're subtracting the 3 over first. I get x squared plus 2x plus 3 equals 0. From here, I do b squared minus 4ac, giving me negative 8. And because that comes out negative, I know that I'm somehow going to have an imaginary number within this. I have to decide if it's going to be imaginary or complex. Because the value for b here is going to be 1 or bigger, I am going to get two complex numbers here because I'll get a real part and an imaginary part. So from here, when I set this up, it's the opposite of b, so -2 plus or minus the square root of what we just got for b squared minus 4ac, and then all over 2 times 1. Then from here, I've got -2 plus or minus. This can simplify to 2i root 2, and then it's all over 2. And once again, I see that this number, and this number are all divisible by the same thing. So I can simplify that one more time to get this answer right here. And then for 10, if I subtract over the 11, I get x squared plus 3 equals 0. From here, b squared minus 4ac gives me -12. So for that, again, I know an imaginary number is going to be involved because I'll be taking the square root of a negative. But because we didn't have a b value here at all, our answer is not going to have a real part. It's just going to have two imaginary solutions. So here I've chosen to solve this by square roots. I've got x squared is equal to -3. Square rooting both sides is going to give me plus and minus. And then I can take out an I here, and that's it. And it's just plus and minus I root 3. So please complete the exit slips associated with this lesson, and then your homework will be practice set 17.